Three types of I/O. Block I/O, large blocks of data. Stream I/O, streams off single characters. Memory mapped I/O, treat I/O device as a memory address. Stall. CPU waits for a resource to be freed, i.e. fetching twice at the same time. Predictions. CPU tries to predict what will happen during a branch in order to be more efficient and avoid stalling. Two types of specular execution. Eager executed immediately without prediction. Speculative executed after predicting the right course of action. Three types of hazards. Data hazard instruction depends on the result of previous instruction. Cannot be pipelined. Structural hazard when two isntructions require the same resource, i.e. ALU or fetch, etc. Control hazard when an instruction depends on the result of a branch. Locality types. Spatial next to each other physically, i.e. 0x1, 0x2, 0x3. Temporal next to each other in terms of last use, i.e. next to each other in the cache BC, it replaces old data. TLB. Translation look-aside buffer stores the recent translations of virtual memory addresses to physical memory addresses so that it doesn't have to be translated again. Types of branch prediction. Static always taken not taken or backward taken, forward not taken BTFNT. Dynamic two-level adaptive or correlation prediction. Subtypes, branch history table, pattern history table, two-level adaptive combines the two. Instruction pipeline. Fetch, execute. Thrashing. Running out of RAM so the computer begins excessively paging data between RAM and disk, causing a massive performance decrease. DMA. Direct memory access. I/O devices can directly access memory rather than needing to go through the CPU. Facilitated by DMA controller. Programmed I/O versus interrupt-driven I/O. Programmed I/O CPU is actively checking status of I/O devices. Interrupt-driven I/O, when the CPU gets an interrupt signal, it saves its state, then begins processing the interrupt service routine. After it finishes, it reloads the saved state and continues. Advantages and disadvantages of multiprocessor systems. Advantages: increased processing power, parallelism, scalability. Disadvantages: complexity, fighting over shared resources, i.e. disk, extra hardware components. Trap versus interrupt. Trap is performed by the software and handled by the software. Interrupt is performed by hardware outside the CPU and is handled by the interrupt service routine. Interrupt vector. An index containing interrupt service routines. Each interrupt corresponds to its own interrupt service routine. Prioritized interrupts. System assigns priority to interrupts and handles them one at a time. Concurrent interrupts. System can handle multiple interrupts at once. List CPU registers. PC, program counter. IR, instruction register. SP, stack pointer. BP, base pointer. General purpose registers, EECs, etc. used for storing information temporarily. Flags or status registers are used to indicate the result of an operation, i.e. zero flag, carry flag, etc. Flags or status registers are used to indicate the result of an operation, i.e. zero flag, carry flag, etc. Memory hierarchy. Registers. Cache memory. RAM. Secondary storage. How is an interrupt handled? When TE CPU receives an interrupt, it saves its current state, then processes the interrupt. Once the interrupt is complete, it loads its previous state and continues execution. Design considerations. FO/IO subsystems. Security. Performance optimization. Scalability. Reliability. Error handling. Out-of-order execution. Reorders the instructions in a program to be more performant based on dependencies and concurrent action.